Hello everyone, it's September 13th. Alright, let's do this. Longest subarray with maximum bitwise AND. You are given an integer array nums of size n. Consider a non-empty subarray from nums that has the maximum possible bitwise AND. In other words, let k be the maximum value of the bitwise AND of any subarray of nums. Then only subarrays with a bitwise AND equal to k should be considered. Return the length of the longest such subarray. A bitwise AND of an array is the bitwise AND of all the numbers in it. A subarray is contiguous. Okay, so I don't know, it's like a sliding window thing. You just and like if it's increase, you keep going. I actually have no idea. Well, the longest subarray, if you have all the numbers, if you line them up, right, to have some zeros, some ones, you know, doesn't matter, we just randomly write something. And if you line them up, and whenever you hit some zero, because if you want a maximum, then you want to find a maximum number first, right? Because maximum number, because it's AND, right? So as long as you have a zero, it's going to become zero. So what you want is to find the largest one, right? The largest, the most to the left. So that can decide. That is the largest. So you cannot get even bigger than that. So that is. So basically, the answer is to find what is the longest that this position is 1, right? Because you can pick by itself and that will work. So you go through the whole thing, and usually you find the largest number, yeah, because the largest number will have the 1 towards the leftmost. So you find that, you record which position it is, and then as you go through, what you get is only that number, right? All the other numbers are gone, right? And you'll do the same thing with the next one, right? With the next one. And it's also the largest. So you go to the largest number, right? Regardless, you go to the largest number, and the largest number will have this one, right? And you'll have, you know, maybe this one, right? You'll have all the ones. And all the other, because all these are zeros, so they will always be 0. So you just find the largest number. That is your result. The largest number is the maximum bitwise AND, because it cannot be bigger than that. It's just not possible, right? Whatever is 1 there, you cannot create a 1, right, from 0. That's basically what it is. So you find that, and the next job is just to find the longest stretch that can give you that value, and then which is exactly the longest stretch with the same value. The same value. That's basically it. Alright, so you go through this array, you find the largest number, right? And then you go through it and then find the largest stretch with this number. So once you hit this number and you start count, you hit a count, you hit it, anything else, you skip. Yeah, because if you do anything, right, you do anything, it's gonna get smaller. Okay, so that is kind of my way of thinking. Let's see if it is correct. It seems correct to me. I don't see as any other way that can make this not work. Well, we'll have to see. Alright, so basically my idea is int max is equal to -1. Okay, for int n of nums. Okay, max is going to math maximum max and n. Okay, so now I have that, and int res equal to 0 for int n nums. Right, and then we say if n is equal to max res plus plus. Actually, no, we need a count. Right, so we do count plus plus. Right, else if it's not equal to, then res equal to math the maximum res and count reset to 0, and at the end we'll return res. Alright, let's try these. It'll work. It does not work. Because your res just set to 1. Nope, if res set to 1, yeah, res should set to 1, because the first time you set is equal, then that's fine. Wait, this count set to 1. But then, yeah, you have this issue. Okay, yeah. So I'll return so if it's equal, I'll count 1. But if it's not equal, I set count to 1. If it is equal, I shall also set count to 1. Right? Yeah, so I can say we only add if count is larger than. Yeah, come on, there gotta be a better way to do this. I just want to count how many. Yeah, if it's not, we set to 0, 0, 0, then f. Okay, I just do this. If at the end return res is equal to 0, if res is equal to 0, we do 1. Otherwise, we do res. Because if res is 0, it basically means we haven't found any. Right? And what troubles me is I see what troubles you. We should just do it one more time. Yeah, I was like, it doesn't make any sense. Why I have to do this a stupid thing? And actually I can just return this, right? I just return this and it will work. So, okay, so this is my theory. It may be wrong, it may be right, it depends. So I believe that this question, the max and of an array must be the max value of the array. Right? That's basically what. So thus the problem is equivalent to finding the longest subarray that contains only the max value. Alright, so it may be wrong, but I feel it's right. Right? I mean, what else can you do? Seriously, what else can you do? I don't know what else can you do. just find the largest number and then you just count. Okay, we have some issue here. Not very confident, but I'm gonna submit it. I think it's right, and it is right. Yeah, it makes, I say, perfect sense, right? That is the way to go. Just find the max. Yeah, it is the final max. Okay, so that will be it, and I don't want to do another one. Let's just call it a day.